Morning, folks. Good morning. Not many are responding. Oh, I'm feeling good, Siddharth. How about you? Good, folks. Ah, very good. Okay, so just a question for you guys. You can use the chat or you can come on voice. Do you think if I come on Zoom 10 minutes earlier, if you have doubts to clear, would that be useful on the chat? Yeah. Okay, so I'll do that. I'll come 10 minutes earlier. I mean, the regular class will start from whatever stipulated time. So that if you have any questions or if you have any nice uh, um, information, comments to discuss about, I'll be there. Okay. All right. Now, let me quickly get into the act. We were discussing about, we finished stresses, equilibrium, strains, continuity, and we started off in terms of constitutive law or material law. Okay, and I focused on primarily linear elastic material to start with because it's the simple material. We figured that there are how many constants for a two-dimensional problem that you have to use to relate between stress and strain. How many constants? How many constants? Ayush, it was 9 before we used hyperelastic formulation, and then it became 6, right? So 6 was what we needed to find out as far as two dimensions are concerned. But the moment it goes to three dimensions, it explodes to 21. Okay, that's what we figured out. And then now we are exploring as to what would be the actual equations would be. Okay, for that reason, we went into a specialized material, a material which shows no difference between one direction and another direction in terms of its properties. Okay, so we're going to use that to derive equations related to stress and strain. Okay, we started with one-dimensional stress, sigma xx. It is sigma xx because it is in the direction of x and on the face whose normal is also x. And then we wanted to derive, we derived it. Right? We got sigma xx to be equal to E, which is the elastic constant times epsilon xx, and epsilon yy to be minus another factor times whatever elongation has occurred in this direction. Okay. And epsilon yy, which is the contraction that has occurred, is a negative nu times sigma xx by E, and there is no shearing strain that has occurred, and therefore zero. And this is what we got from just applying one directional stress. And then we discussed about something else, and that was this: if I take the same bar, applied a force F1 first, and got the elongation to be delta 1, I applied a force F2 here, and I got the deflection to be delta 2. If I put both of them together, and apply at once F1 plus F2, then I would get the total deflection here to be equal to delta 1 plus delta 2 for a linear elastic material. Okay. This is also something that we discussed, and we said, okay, there is this possibility of superposition that we can advantageously use uh, if we have to superimpose whatever we get for sigma yy and tau xy. Okay, that's where we were. Okay. I'm hoping that there are no questions in relation to that. If if there is a confusion or question, you can ask me now. Okay, so let's write this in a matrix form. So sigma, I'm sorry, epsilon xx, epsilon yy, gamma xy is equal to help me out, please. One of you come on voice, help me out on this. Times sigma xx, sigma yy, tau xy. In this scenario, what would I get here? Quickly.
1 by E
1 by E
0 0
0 0
minus mu by E
minus mu by E 0 0 0
0
0.
0 0.
Okay. Now, are you ready for a 1 mark answer? Yes or no?
Yes, sir.
Okay. Should I include all those on chat also? Is that okay? Those
Yes,
on
sir.
camera can say yes or no. All right. Okay. Very simple. What is the difference between writing it like this and writing it this way, which we did earlier, which is epsilon xx, epsilon yy, gamma xy here? This C, no? What's the difference between these two? Clock is ticking.
Those matrices are inverse.
It
It's
could be
just
inverse, but anything else? Anything else that by writing these, what are you conveying? Those others can use chat box. Let's see who gets that 1 mark. I could increase the stakes if nobody is answering yet. Watch this. This is assigned to this. This is assigned to this. Clue. The right hand side is assigned to left hand side. The first case epsilon terms of, but later, okay. Very close, Janisha, but can you be a little bit more specific? Can you be a little bit more specific? Janisha has some answer. And she says epsilon in terms of sigma, sigma in terms of epsilon. Hyperelastic equation, yeah, it can be an hyperelastic equation, but this is an explicit equation. Okay, directly we have written, we didn't write it. Yeah, that is fine. It could be complementary synergy, this hyperelastic formulation, all those are fine. But I have written these equations explicitly. But there is something that I convey by writing this or writing this. The clue is in this. I started with saying that. Why am I building this so much? Because this is important. Anybody who is
Sir, in
close.
one
Oh,
of the
wait.
we
Sriraj has
applied
an answer. Sriraj, Sriraj is here. Sriraj has an answer. He says we need to know sigma, tau, and e in first case, but we need to know epsilon and sigma in second case. In the first case, we apply. Fantastic, Ayush. Ayush and Sriraj get 1 point each. See here, I'm applying stress and finding out strain. Here I'm applying strain, I'm finding out stress. Is this clear? Right? What did we do here? We applied sigma and then sought to find out what would be the strain. All right. So if the control shifts from stress to strain, the equation also shifts from stress to strain. Is this clear? Yeah, very good. Very good. So one thing that we have written now is this equation, which has to do with just applying sigma xx alone. All right. All right. And we said, okay, there is superposition that is possible. We're going to use that and write what would happen in a general case. Okay. Okay. If you have any questions, you can ask me. Okay. Supposing I apply on an elemental body, this is P, this is x direction, y direction, sigma xx. So a state of stress is what is given over here. Tau xy. So the three stresses are, all the three stresses are present as far as this stress state is concerned. Now, how do I look at it using superposition principle? How shall I look at it so that I can write these equations easily, quickly? How shall I look at this scenario? And let's say I use superposition principle. Go ahead. What shall I do? Sriraj, what shall I do? I have a general case here. So I also know that there is superposition possible. Can I combine these two and get an idea of how to now write for this general case? I'm asking a very simple question. What did we do here? What did we apply here in this for this equation? What did we apply for this? We applied only sigma xx. Is it not? We applied only sigma xx and looked at what is the elongation in x direction, contraction in the other direction, and wrote this. I want to write it for a general case. So what shall I do? And superposition is something that is applicable. Go ahead. You
Apply
don't have to
stress
break.
along X and then along Y and then add them.
Oh, fantastic, Sharath. You get 1 point. So I can think of this as applying along x direction plus, I'll not write plus here, I'll write it later, along the y direction, and the other one right. I've now split into three of them. Each one of them is easily handleable right now. Okay, so I'm going to call this as 1, 2, and 3. Okay, and therefore epsilon for this is equal to epsilon for 1 plus epsilon for 2 plus epsilon for 3. Got it? Now it's easy for me, right? Can you tell me what I will get? So this is for what? This is for This is for what
Done.
strains did I get? This is for
Like stress only along.
what case? This case 1, case 2, case 3. This is for case
Case 1.
Yes, one.
case 1. Case 1. This is for case 1. Correct? I already found out the strain. Okay. When I say this, I mean the total strain matrix. Okay. For 2, is it possible to easily guess what it would be? For 2, epsilon xx, epsilon yy, gamma xy. For the second case, 2 should be equal to give me this matrix
0, 1 by
0,
E,
0,
1 by E,
down or up,
sideways.
sideways. 1 by e here,
Hmm.
1 by e.
Yes.
Let's first write this. This is 0, 0,
Hmm.
0, 0, 0. Oh, this is fine. Correct?
Yes.
Tell me the other ones.
The second value in the first
Second
this
value in this first row should be
should be
for first of all, sigma xx is not
no.
taking part.
Hmm.
Tau xy is not taking part.
Hmm.
Right? So automatically
the middle value should be 1 by E.
the middle value should be 1 by e. Fantastic. This should be 1 by e.
And the second value in the first row should be
Very good.
minus mu by E.
Very good, Yush. Yes. And this is 0.
Hmm.
Right? So simple. Like I am now able to write for this and I am able to write for this. Beautiful. Only 3 is left now. Okay. Any questions so far? So simple. Now, if I add this and add this, I would have added for this case and this case together. All right. I need one more for this case. Once I am done, beautiful, no problem, over. Okay. So let's combine these two. Okay, we'll do it later then. All right. Okay. So now just remember this. Remember this. We'll come back to this once we finish the third one. Okay. Third one, I need a clue from you. For the third one, I need a clue from you. This is shear. I'm applying what kind of stress state is this? If I look at it only this, if I look at only this,
Shear stress.
what shear? What shear? There's something that we attribute it to. There's only shear, so pure shear. Very good. Okay. So this is a pure shear state for which I want to find out. Okay. The earlier ones I already did. So I can even write that here, epsilon xx, epsilon yy, gamma xy is equal to, now I'm going to combine the two, okay? This is sigma xx, sigma yy, gamma xy. I'm going to put 1 plus 2, okay? 1 plus 2. Can you quickly help me out? This is
1 by
1 by,
E, 1 by
very
E,
good.
minus
My,
mu by E, 0, minus mu by E, 1 by E, 0, 0, 0, 0.
fantastic. Very good. Thanks, Ayush. Okay, 1 and 2 I've done. 3 only is left. I need a clue from you. Anything that I can do so that I'll be able to do for this. I know only if I apply normal stress, I know how the material responds. Okay. I don't know how it would respond for a pure shear. I need to do something. 2 marks. I need to do some jugglery so that it's possible for me to now find for that also. Anyone on camera use Mohr circle and do what, Anirudh?
Apply a stress P which is 0 and then find.
Mm, can you be more clear? Or we are now looking at how do I get strains for this pure shear condition. So consider virtual sigma and then substitute that 0. Mm, somebody Anirudh says we know sigma xx and sigma y, so we can get tau xy. Okay, but I have only tau xy. Good, Anirudh, but I have only tau xy. You're very close, Anirudh. You can come on camera also. There is pure shear, tau xy. And what Anirudh is saying, change the angle using, why Mohr circle here? Change the angle of this fantastic. Chaitanya and Anirudh get split into 1 and 1 mark. Basically, I can look at this. So if I have pure shear like this, and this is tau xy, this is pertaining to x and y like this, right? This is point P. Another way of looking at this is, of course, it's a pure shear condition. One of you said Mohr circle. So for a pure shear condition, the normal stresses are 0, which means the center is at the 0. Correct? You did the assignment, so I'm assuming you can immediately calculate the summation of the normal stress is 0 at the center, right? And tau xy should be the value of the radius of the Mohr circle. Where are we here? We are here, right? This is tau, this is sigma. If I look at this side, I'm here. If I look at this side, I'm here. Are you with me so far? Right? Now, let's use whatever Chaitanya has said. What angle should I use in order to make use of this kind of scenario? In this scenario, I had supplied sigma xx and sigma yy and this I forced to 0, correct? I pulled in x direction and y direction, or in other words, I applied sigma in x direction and sigma in y direction, and did not apply any shear stress. That's how I found this out. So what should I do here? Chaitanya rightly says, change the angle. So what should I do here? I should change the orientation of x and y, correct? Which orientation? Why 45 degrees? You're right, Janisha. Why 45 degrees? Because I want to now go into this scenario where the shear stress is 0, right? So this angle that I'm looking at is 2 times pi by 4, correct? And therefore 45 degrees. Janisha also gets a point. So if I take like this, which is 45 degrees, this is 45 degrees, then for the same stress state, which is the pure shear, I can now write down what would be the pure normal stresses. Correct? Correct? And what are they? Here I have Here I have sigma x prime, and this is sigma y prime. Just listen to me carefully. And what is the value? So this is sigma x prime, and this is sigma y prime. Okay. And what are these values? Am I right here? Have I written it correctly? No. I should start from where my x is and go in this direction, not this. Right? Is that correct? Yes or no? You can say yes or you can say no. Or you can say confused. You did more circle, that's why I'm using more circle here, just the previous assignment. Anyway, do that. What would I get for this, Janisha? What would I get for this? Quickly. What would I get for sigma x prime if it is 45 degrees? I can use the Morse circle to immediately state this will be value equal to tau xy, correct? And here I would get it as minus tau xy, correct? Beautiful. Of course, no. So supposing I shear it, what would happen? It would go like this, correct? It would extend in this direction and it would contract in the other direction. I would get something like this, correct? Right? Naturally so. Then it is substantiated by this. It is like compressing in one direction, extending in the other direction. All right. So if I substitute in this equation tau xy and minus tau xy and then rotate it back, I should get for the pure shear. Clear about it? Yes or no? Should I repeat it once more? For that, you can say yes or no. Should I repeat it once more? Very simple idea. Same stress state for both of them. So I take it at the 45-degree angle so that only normal stresses are present. And I find out what those normal stresses are. Normal stresses are tau xy and tau minus tau xy. Now the scenario is very similar to what I have written for the cases 1 plus 2. Okay, so far okay. If it is clear to you, let me erase this and now write down. Now write down epsilon. What should I write here? What should I write here and what should I write here? This is tau xy, correct? When I say tau xy, I mean that value, okay? Okay. If you are confused, let me take it as just tau, okay? And the other one happens to be minus tau, correct? Right? The other one was 0. All right. What can I write over here? What can I write over here in order to get the strains? I can use this principle directly. Yes or no? Yeah. So help me out. 1 by E minus nu by E 0 minus du by E 1 by E 0 0 0 0. Fine. This is the applied sigma xx, sigma yy, and I've just taken this and substituted over here. What would I get as a strain here in this? Quickly, 1 mark. What would be the strain here? How would I write? Think. Fantastic. Who is that? Chaitanya, you're right, man. It is x prime, y prime, y prime, x prime, y prime. Why? Because it's not in this axis, but along this axis that I have now represented everything. Right? Is this clear to you? Because I have just rotated completely and looked at that scenario freshly. That scenario happened to be this plus this in that direction. Right? So I'm able to now write. So far, okay? Can you write down what is epsilon xx here? Epsilon x prime here. What would you get? Quickly. What did you get? Those on camera. Just do the
Tau,
multiplication and tell me.
tau by E
Ah, tau by
plus
E.
mu tau by E.
Okay. And then I can now factor it.
1 plus
Correct? And epsilon y prime
minus mu minus of mu plus 1. Same thing, minus.
minus. Very good. Same thing, minus. Very good. Okay. So far, okay. So now what I'm going to do is I'm going to use more circle again, right? And what is gamma x prime y prime? What is gamma x prime y prime?
0.
Look at the equation
0.
and tell me. It's 0. It is 0. All right. So which plane am I in if it is normal strain and shear strain? Which plane am I in? If I now change it to strain more circle. Remember, strain more circle and stress more circle are equivalent, correct? So I have a normal strain over here, shear strain by 2 here, correct? All right. Which is this x prime? Which is that plane? Which is the plane? On the strain axis. Oh, just call it as Anirudh, call it as normal strain axis. Okay, so because this is normal, this is shear strain, normal strain axis. So I'm now looking at this, which is tau by E times 1 plus mu, and this is minus tau by E into 1 plus mu. All right. Now tell me, I have it as 45 degrees. I want it in 0 degrees. So what should I do here? I reverse, correct? I reverse the direction, right? So I'm here right now. I want to now go to minus 45 degrees. Go back to minus 45 degrees, correct? If I go back to minus 45 degrees, where will I end up in this Mohr circle?
On the y-axis.
On the y-axis, all right? So can I find out this value then? Can I find this value?
Yes.
What is it?
Tau by E into mu plus 1.
Very good. So shall I erase this? Is this okay? Shall I erase this? Yeah. So what I get now is tau xy, sorry, gamma xy, which is equal to twice epsilon xy is equal to 2 times 1 plus mu divided by E. Got it? Right? And on this axis, what is epsilon xx and epsilon yy? On this axis, what is epsilon xx and epsilon yy?
0.
0. So I'm now going to write that now. Epsilon xx, epsilon yy, gamma xy is equal to sigma xx, sigma yy, tau xy. I said this equal to 0, this equal to 0 for the third case, this case. All right. All right. These two have to be 0, so I'll put the 0. Okay. All right. The other thing that I notice is these two are 0 because I have epsilon xx is equal to epsilon yy is equal to 0 for this condition, for the third condition. Correct? And therefore, the two zeros come in. After that, I just need to insert this over here. So it is 2 into 1 plus nu divided by e. Got it? Yeah. Now it's very simple. I just have to add this to this. I have added for these three cases. All right. So if I do that, I'm just going to add now. Oh, that's very simple. All I have to do is I take this 2 by 2 matrix and insert it over here. So let me insert it now. It is 1 by e minus nu by e minus nu by e minus nu by e 1 by e. Fantastic. Now for a general case, I'm being able to write stress strain relationship. Is this clear to you? All right. Shall I erase this side? Any questions? Any questions? Any questions? If I have to write explicitly, it is epsilon xx is equal to 1 by e times sigma xx minus nu sigma yy, right? Epsilon yy is equal to 1 by e sigma yy minus nu sigma xx. Gamma xy is equal to is equal to is equal to tau yx times is equal to so far okay? Yeah. Now, given these two, I'm going to erase this, okay? I want to have the inverse relationship. Can you quickly tell me what would be sigma xx in terms of epsilon xx and epsilon y? You can use these two equations because this equation is very simple. I can just reverse it and write tau xy is equal to e by 2 into 1 plus nu times gamma xy. This is very simple. I need to now write for these two. If I do that, I have the inverse relationship available. And that's very simple for me. I just have to manipulate this and get it. What would that be? E into
E into epsilon xx plus
epsilon xx plus
nu sigma yy.
sigma shouldn't come this side. Remember, I need to now eliminate in such a way I get sigma xx in terms of these two. Is it not? I want to write the reverse relationship. Sigma xx in terms of epsilon xx and epsilon yy. Sigma yy in terms of epsilon xx and epsilon yy. Of course, they will also turn out to be symmetric. That's pretty simple, no? I just have to multiply throughout by nu, right?
E into
You E into
epsilon xx plus epsilon yy divided by 1 by me.
Is that what you get?
Epsilon xx plus new epsilon yy by 1 minus
Epsilon xx plus
new
new
epsilon
yy times E
by 1 minus mu square.
1 minus nu square. Is it 1 minus nu square? Yeah. So that's what I'll get. Right. So I'm now able to write in the other form also. I can also write this as sigma xx, sigma yy, tau xy is equal to, I can put that, I can take out E separately. 1 minus nu square. What people do is they take the common denominator and put it outside, but it doesn't matter here. You can just write it as this plus nu by 1 minus nu square, 0, nu by 1 minus nu square, 1 by 1 minus nu square, 0, 0, 0, 1 by 2 into 1 plus 2 into 1 plus nu. This scenario is when you apply the strain and seek to find out what happens to the stresses. Here, in the other case, here you apply stresses and find out what happens in the deformation of the material. So far, so good. Any questions? Any questions you have? Is this clear? If this is clear, I have one request from you, one request to you, which is this. I have now written this. I have now written this. I want to seek to find out. I have this material, let's say, but uniformly, so sigma xx, sigma yy, and tau xy. General scenario is present, but also there is an increase in temperature by delta T. Are you with me so far? There is an increase in temperature. There is also the stress present. In the breakout room, I want you to calculate and come back 5 minutes. Okay? Ready? Is this clear to you? There is a rise in temperature. Apart from that, it's the general state of stress. Okay? Go ahead, breakout rooms. Let me see how many of you have come. You can go ahead, please. 5 minutes is what I'm going to assign. Mega, can you move to the breakout room quickly? Megha, are you there? See, what's happening is she has just turned it on and gone. Unfortunately, why do that here?
Suppose they thought that later on the recorded video they can see and they can.
Yeah, but still, why do this? It's a practice that is unethical, isn't it, Meha? She's not there.
Now see.
She has just left. What do we do?
This person we are teaching. This person I first time encountering in the song course.
Mm-hmm. Bhavani has been attending for the past few days. I guess they're having some internet issues.
So there is one person who is not there in the attendance list, but he, I mean, once or twice I have
Name?
name I don't remember, but his roll number is
Ujjwal,
ME
Ujjwal sir.
ME16B something. There are two in the list,
Oh,
but usually there is one more.
I see. I don't know. We'll find out. We'll figure out.
I'll just go check in one of the breakout rooms.
Sure. Yeah.
Just like that.
Yeah. You guys can go and just do that. Most probably you will find them just waiting.
Oh,
Uh, so what's next? Hello.
Hi.
Uh,
so that's the thing. Okay, I just
okay.
Okay. Were you people able to do it? Karthik? You don't have to answer, but you can say yes or no that you have discussed. Karthik. Okay. Okay, you have discussed. So let me close all the rooms now. We'll get back to business. Okay, which group wants to go? One of you can help me out. How do I now write? There's an increase in temperature and this. We'll wrap it up with this. About 7 or 8 have left. Can you believe it? Why attend such classes here? Just bunk over. Yeah, go ahead before I get too bogged down by that. Sharat, Ayush, Vaibhav.
Can we just add the strain due to temperature?
That's all. You're as simple as that. So this will be nothing but 1 by E minus nu by E 0 minus nu by E minus nu by E 1 by E 0 0 0 2 into 1 plus nu by E plus times, I'm sorry, times sigma xx, sigma yy, tau xy. Now tell me, Sharath,
Plus
I'll put it as
alpha
put it as
delta.
minus, okay? So I'll put it as minus so that I have sufficient space here. So minus, go ahead,
Alpha delta.
alpha delta t,
Alpha delta.
alpha delta t,
0.
0. Oh, fantastic. As simple as that. Good, Sharath. So I now know what to do with temperature. If you want to realize a reverse relationship is simple. You just do the inverse of whatever you have done that earlier. You can do that. That's it. Over. Okay. You can test for yourself by applying certain things. That's it. Yes, Ayush, correct. You just have to add. Okay. We have just wrapped up simple ideas of stress and strain. Okay. We'll come to that when bending things like plastic, Sriraj. There is dissipation that is occurring. I may probably discuss that at the end of this strength of materials class. Okay, one last point. How many equations here? How many equations have I written? I've written 3 equations. Did I add any additional unknowns? I did not add any. Forget about this right now. For alpha is also not an unknown. It's given to us. So only 3 equations, 0 unknowns. Now I put them in the table, right? I had 8 unknowns, 5 equations. Now I'm adding these 3 equations. They balance out. I should be able to solve this set of equations. So in a forthcoming class, we'll solve one problem put by using all those equations together. Okay. All right. Now we have a generalized framework with which we can use and solve problems which are 2-dimensional or 3-dimensional. Okay. There may be a complexity, but we have the equations to be solved. All right. If no questions, thank you. Have a good day.
Thank you, sir.
Middle of the week.
Thank you.
Listen.
Thank you.
Thank you,
Bye.
sir.
Thank you, sir.